Okay, welcome back. And now we're going to talk about finding the average value of a function. So let's start with averages in general. So in the discrete case, we have taking an average of a set of numbers, right? So let's say if we have an n numbers, the way we find the average of the set of distinct discrete numbers is we just add up those numbers and divide by the total number of numbers or our sample size that we have, okay? So that's how we typically calculate an average. So let's take a function though. So let's consider f of x over a closed interval a, b. So what we could do is we could, well here's the thing, we can't do it this way because there's an infinite number of x values that we could plug into here to get the height, right? So we can't do it this way. So why don't we do this? Let's go back to dealing with subintervals. So let's take n subintervals. Okay? And so remember, delta x is equal to b minus a over n, right? And so this will give us our intervals, right? So we'll have our intervals will be from x of I minus 1, comma, x of I for I equals 0 to n, right? Just like before. And then what we're going to do is we're going to just choose a sample point, right? So we're going to choose, x of I star, right? A sample point from each one of the intervals, right? Okay? So now, let's use these endpoints, right? And so what we can do is we can define the average of the function equal to x1 star plus x2 star plus, x3 star all the way to x of n, x star sub n, or x of n star. And of course, how many of these are we going to have? We're going to have n, right? Now, okay, let's look at this further. Since we know that delta x is equal to this, then also n, right? So this implies n is equal to b minus a over delta x. So let's do that, okay? So let's change this to b minus a over delta x, okay? And so now what I'm going to do is I'm going to simplify this a little more, because all of this is just the summation of f of x of I, right? So I'm going to write this as a summation for I equals 1 to n of f of x of I star, right? Divided by b minus a over delta x. Okay, now, Now what I'm going to do is I'm going to multiply by the reciprocal and then write this as, oops, delta x over b minus a times the summation of I equals 1 to n of f of x sub I star. And now what I'm going to do is I'm going to distribute the delta x into the summation. So then this is going to become 1 over b minus a times the summation for I equals 1 to n of f of x sub I star times delta x. And guess what? Now look what we have. We've got this Riemann sum multiplied by 1 over b minus a. Okay? So now, guess what I'm going to do? I'm going to use limits. So let's do that. So now what I'm going to do is I'm going to take the limit as n approaches infinity, right? So now I'm going to start increasing the number of subintervals to infinity. And what happens here? This is going to be the limit as what? B minus a of the summation I equals 1 to infinity of f of x sub I star delta x. Well, this comes out, so this is going to equal 1 over b minus a times the limit as not x n approaches infinity of the Riemann sum. Oops. Okay, now we know what happens to this. This becomes an integral, this becomes dx. And then our sample point just becomes x because it just reduces, basically the subinterval reduces to 1 point at x. So at an infinite number of x's now. So this gives us 1 minus b over a times the integral from a to b, right? This gives us the definite integral of f of x dx. And that is how we find the average value of a function. Okay, so now we're going to do some examples. Have a great day.